Hello, everybody. Thank you so much for joining us on our webinar today. My name is Eric Farrell. I'm the product specialist at Milestone for Digestion. Today, I'll be taking you through single reaction chamber digestion technology and its application to the mining and geochemistry fields. So before we get into the presentation, I wanted to talk a little bit about what causes the most errors in chemical analysis. It probably shouldn't surprise you that it's sample preparation and human error. These are two things that we have the most control over. You want to make sure that whenever you're preparing your samples, that you're minimizing human error as best as you can, and you're making sure that your workflow is as streamlined as possible to help further mitigate any chances of having any errors in your subsequent analysis. Most modern analytical equipment, such as ICP-OES and ICP-MS, typically will give you answers in a few minutes or seconds. However, it's been seen that the sample preparation technique itself is actually the bottleneck to a good, accurate analysis because sample prep requires time, significant use of reagents, and maybe even cumbersome handling. So now let's get into the mining industry, the meat and the potatoes of today's presentation. So first I'll start with the picture on the right. This is my colleague Maya, who visited Capstone Copper to install some ethos digestion systems. You can see her next to the tire over there. But getting into the types of samples and the work that you're doing, it's very important that whatever type of analysis we're doing does not get held up, because accurate metal analysis is pivotal to supporting your mining operations and downstream processes. If there's any bottlenecks or there's any holdups in your sample prep, then you have a holdup in your operation. There's a lot of different types of samples that you'll be characterizing, and going from whole rocks to drill cores, drill cuttings, soils, stream sediments, till, clays, waters, etc. Again, the analysis is done via ICP-OES and ICP-MS, especially for making sure we know the load levels that are in there. And samples may be either completely digested or you may be doing a leach for elements of interest. Now, the geochemistry industry is going to be very similar as far as the types of samples you're working with, but the application may be just slightly different. Typically, this is done to help meet exploration requirements and for research purposes. Analysis is done at the low level via ICP-MS, and also you have some work at ICP-OES. Sample types are going to be similar, but you're also going to include precious metals, leaches, ores, whole rock analysis, crude oil, and coal. Crude oil and coal are two of the organic samples that will basically make up most of the geochemistry applications that you're doing. And sample types, as you'll learn, will often require high temperature and complex acid mixtures to achieve complete digestion. Now let's get into some of the different sample preparation techniques that are out there. First, we have hot blocks or open vessel systems on the left, and then on the right side, we have microwave systems, rotor-based systems, and SRC technology. First, let's talk a little bit about open vessel or hot block systems. Hot block systems are very good because they're inexpensive capital expense, and you're only limited by the amount of fume hood space you have as far as your throughput is concerned. However, there are some inherent limitations to this type of technology. You're working at atmospheric pressure, so that means you can't exceed the boiling points of your reagents at atmospheric pressure. This can result in incomplete digestions in many cases, and even long digestions where you can have a digestion that can take multiple hours, for example, with EPA 3050. Open vessel systems are typically very labor intensive because you have to sit in front of them, babysit them. They require a lot of acid, and they have high reagent blanks because you have to constantly keep adding acid to them. And they're open to the environment, which can also cause cross-contamination or contamination from the environment. And lastly, you also have loss of volatile elements. So what is it that closed vessel microwave digestion can do over hot blocks or open vessel systems? First is going to be speed and productivity. Because we can work beyond atmospheric pressure, we can exceed the boiling points of our reagents, which is going to mean that we can have much faster digestion. The digestion that may have taken 3 hours, for example, on a hot block can take an hour or less on a closed vessel system. Digestion quality is going to be much higher too, because with the higher temperature we're able to achieve higher quality digestions. There's been tremendous strides in the safety of microwaves compared to earlier versions. So safety is paramount here, but there's a lot of safety that's been built into our systems, such as venting reseal technology, pressure responsive self-resealing doors, and easy temp contactless temperature sensing. Big strides from when this technology was invented over 30 years ago. It's very easy to use as well because we have built-in application libraries. So you can simply go into the terminal, select whichever method you need, and it's easy handling as well. We have full control over the temperature, and we monitor and we control and accommodate the pressure, using our venting and reseal technology. So whichever type of system you choose, whether it's open vessel or closed vessel, is really going to depend on your application, the type of sample you're doing, the sample weight, and your analysis, whether it's ICP OES or ICP-MS. Going to a closed vessel system is going to be more beneficial, especially for ICP-MS, because it's going to have lower blank values. Also, the system needs to be able to meet your lab's needs as far as meeting your productivity demands, as well as being easy enough to use for your laboratory users and your lab technicians. So now let's get into inorganic samples, which is the predominant type of samples that we're going to be working with. Inorganic samples have a wide variety of sample compositions, which you'll see. I have some examples coming up soon. Sample preparation procedures that you're going to do depend on the chemical nature of the material. That's as far as what acids you're going to use, because a lot of these samples are very different in their chemical composition. So they're going to require different acids, and they're also going to require different temperatures and may result in different pressures that are going to be generated. So the types of samples we're working with are ceramics. These can be aluminas, aluminum oxides, geochemical materials such as ores, oxides, and rocks, maybe even precious metals, platinum, gold, silver, for example, maybe even some catalysts you may be working with, for example, on an aluminum silicate matrix. Now, most samples that are inorganic, when you increase the sample mass, there's not a subsequent increase in pressure, unlike there is with organic samples. So here's an example where we took 1 gram of copper concentrate and we digested this. You could take a look at the blue line. You can see the blue line's only about 25 bar. Now we take the same sample and we increase the mass 2.5 times. Our pressure is still at about 25 bar, even though we're only at 2.5 grams of sample. If this were an organic sample, such as coal or an oil, as you increase the sample mass, you're going to have a subsequent increase in pressure as well. Now, working with whole rock samples, you're going to want to make sure that you reduce them to a fine powder as best as possible. This is going to help increase the contact surface with the acid and ensure that you have a complete digestion of your sample. If you take large chunks of your sample and don't break them up into a fine powder and don't increase surface area contact with your acid, you may get an incomplete digestion in your sample. So for that reason, we like to grind everything as fine as possible to increase that surface area. When using the ultrawave, we like to use large vials. We have a 7-position rack, which has 40 ml vials. These are very good for some of these samples. And we're typically weighing a small sample amount, maybe even 50 milligrams up to 300 milligrams of sample. So there's a lot of different acids that are used within organic samples. So of course, we have our most commonly used reagents, nitric and HCl, but you also have aqua regia, which is a 3-to-1 mixture of HCl to nitric. That's used for dissolving metals or acid leaching from soil samples. We did this as an example later. It can also be used in its reverse form as reverse aqua regia, which is a 3-to-1 ratio of nitric to HCl. HF is also used in many cases for decomposition of silicates, as well as for digestion of titanium and tungsten oxides. There are other acids that are used as well, such as sulfuric and phosphoric acids, as well as perchloric acid on very rare occasions. Some of these acids can be minimized with a closed vessel system, especially the ultrawave. We want to use as little of some of these as possible, especially perchloric acid, due to the nature of the type of acid that it is. But sulfuric and phosphoric are typically used for alumina-based samples. You'll see some of that used as well. With the ultrawave, because we can go to higher temperatures, you can reduce some of the acid that you are using. Now let's go ahead and get into the ultrawave, the single reaction chamber technology. But before we do that, let's get a little let's get a little understanding of rotor-based technology from which SRC technology evolved. So rotor-based systems have been around for well over 30 years in many laboratories. However, there are some inherent limitations to the technology. The vessels are all made of polymers, so you can only go so hot for so long, typically 30 to 60 minutes at temperature. Each vessel is at its own temperature and pressure, which means that you need to run samples of similar matrices together. Vessel handling requires multiple steps. This includes vessel assembly, disassembly, and manual venting of your vessels. And vessel liners may require intensive cleaning depending on your analyte levels. So in order to overcome these inherent limitations of rotor-based microwaves, that's where we came out with SRC technology. Now here I have a video which is going to illustrate the workflow of SRC technology. First, we have, instead of individual reaction vessels, we have vials with loose fitting caps. We take our vials, add our acid, add our sample, place our loose fitting cap on top, suspend that from the top of the rack, and that will subsequently be lowered down into a baseload of acidified water. This makes sure all of our samples are at the same temperature and pressure conditions, which allows us to run mixed batch samples. Next thing we do is we pre-pressurize the system with 40 bar of nitrogen. This does two things. This raises the boiling points of all our reagents and prevents cross-contamination between the samples. It's this nitrogen pre-pressurization that allows us to use vials with loose fitting caps. Next step is going to be your standard microwave program where we ramp up the temperature and we hold the temperature. In this example, we're going up to 250 degrees Celsius. So once we reach 250 Celsius, we have the dissolution of our samples in this example, which happens right here. This is your standard hold as even you would have with a rotor-based system. So this part of the workflow is similar. However, it's going to vary here, where instead of having air cooling, we're going to use water cooling, a powerful external chiller, to rapidly cool down the reaction chamber down to 80 degrees Celsius, which is 20 degrees below the boiling point of water. Once we do that, we're going to slowly depressurize the system at a rate of about 8 bar per minute. This takes the place of our vessel disassembly, where we would have to disassemble and manually vent our vessels in a rotor-based system. Next thing we do is we take our samples out once it's completely depressurized, do a quantitative transfer to a 50 ml centrifuge vial or 25 ml centrifuge vial, and go ahead and run it on your ICP OES or your ICP-MS. And that's the workflow of how SRC technology works. So as you saw from the previous slide, samples and reagents are placed in digestion vials. We're using vials with loose fitting caps. We have 3 different types of vial materials available. We have disposable borosilicate glass, where if your application allows for it, you can simply throw that in the garbage. We also have quartz and Teflon materials that are available as well. So mixed samples with a rotor-based system can be a challenge because anytime you're running a rotor-based system, you have individual reaction vessels that are separate chemical reactions taking place separate from one another, and we're outputting the microwave energy to the entire cavity, to all of them. So for that, to all of the samples, which means we need to run samples of similar reactivities. So on a rotor-based system, if I had environmental matrices, food, and pharmaceutical samples, I would have to run them separately because of their different reactivities. However, with the ultrawave with that base load of acidified water and my samples being immersed in it ensures that all samples are at the same temperature and pressure conditions regardless of sample type, weight, and acid chemistry. This ensures you're achieving optimal digestion quality in all positions, and essentially you can have basically 1 or 2 microwave methods for all different samples that you're running. So SRC technology can go up to much higher temperatures and pressures than you can with rotor-based systems, up to 300 C and 199 bar. Maximum operating temperature of SRC technology is 280 degrees Celsius. Compare that to a rotor-based system, which is only about 240 Celsius for maybe 30 to 60 minutes at a time. SRC technology is going to allow you to digest the most difficult samples, large sample amounts, and even routine samples, mixed or batch samples. You can run them however you want. And it's even going to give, with its superior workflow, it's going to give superior throughput even for medium or harder to digest samples. SRC technology is compatible with any type of acid because all the critical components of the system are made of hastaloid, mainly the nitrogen in, nitrogen out lines, and all the other critical components that are in the main manifold. So this allows you to run HCl and everything, any type of acid, all with vials with loose fitting caps. There's no restrictions on the types of acids that you can use with SRC technology. Now let's take a look at some practical examples of some samples that we run. But first, let's go a little bit into guidelines for how you would run inorganic samples. Typically, you're going to work with a low sample mass, about 0.1 to 0.3 grams. Reagents you're going to use are going to be aqua regia, 3:1 ratio of HCl to nitric. You can be also using HF, sulfuric, phosphoric, or fluoroboric acid. A working temperature is going to be anywhere from 220 up to 280, 280 for those stable organics or stable inorganics. And if you're running this on a rotor-based system, you would want to make sure that you're using a high pressure rotor, such as our SK15 or SRC technology, of course. So here's our first example here. Our first example is, this is the previous situation where the client was running a 3-acid digestion with nitric, HCl, and HF in a traditional rotor-based microwave. They had issues with silver recovery and other elements of interest were being lost. So the goal was they wanted to see, can Milestone with the ultrawave provide a better digestion quality or leaching quality than the client's traditional rotor-based microwave? So what we did here was we took 0.2 grams of sample and we digested it with HCl, nitric, and HF with different amounts of reagents. So in one single run, we were able to do a method development run where we were able to run 0.2 grams with different acid chemistries, something that's uniquely possible with the ultrawave. We then ran a 25-minute ramp to 260 with a 15-minute hold at 260. And what we did was we digested the samples, or this is basically a leach. We digested the samples, leached them out, and then we sent them back to the client. And the client told us, yes, that the recovery that we had obtained using SRC technology was in fact better than their traditional rotor-based microwave. Next was another previous situation from a rotor-based microwave. This client was digesting molybdenum sulfide at 190 C for 20 minutes in a 2-step digestion. They had trouble breaking down the carbon in the sample. This molybdenum sulfide sample can contain a certain amount of carbon in it. They would have to do a 2-step digestion because they would do 1 step for nitric, 1 step for HCl because of the pressure buildup inside the vessels. So the goal was to see, can we get a complete digestion of this molybdenum sulfide sample, including all of the carbon content? So what we did here was we digested 0.2 grams of sample with HCl, nitric, and fluoroboric acid. We actually did this in a mixed batch run to do a method development run when we had done this to see what would be the optimal acid chemistry. So we did a few digestions and we were able to went up to 260 C for 15 minutes. And we did result in complete digestion of all molybdenum sulfide sample, all of the molybdenum sulfide sample, including the carbon that was left over previously in their rotor-based microwave. Next is zinc oxide. Zinc oxide is a pretty standard sample. Client sent us a sample for digestion and subsequent analysis. They wanted to find a method that achieves complete digestion of all of their samples. Samples were digested with 50 to 100 milligrams of sample with 5 mils of nitric and 1 mil of HF. We found that the nitric and HF digestion were actually the best conditions because with the ultrawave, you can run those mixed batch samples for a method development run. And we found that 50 to 100 milligrams of sample with only 5 mils of nitric and 1 mil of HF was all that was required to get a complete digestion of zinc oxide. Next was a copper ore sample that was sent to us for digestion. The goal was to find a complete digestion of both ore samples that were sent to us. So we did a digestion on the ultrawave using 200 milligrams of sample using 2 different acid chemistries. Digestion on the ultrawave resulted in complete digestion using both acid chemistries. But what's unique about the ultrawave is it allows us to run this with HF as well as with fluoroboric acid in separate runs because we have different acid chemistries. The ultrawave is able to support mixed batch runs for method development. Next is a sample of cement and bitumen we had received. The goal here was to digester samples and develop a method for complete digestion of the samples so they can be subsequently analyzed. The samples that we have were cement sample and bitumen. The cement sample was digested using 100 milligrams of sample with 3 mils of phosphoric, 4 mils of nitric, and 3 mils of fluoroboric. And the bitumen being an organic sample, we worked with 50 milligrams of sample, and we only required nitric and peroxide. What we saw from this experiment was the bitumen digested much more easily with nitric and peroxide, whereas the cement, being a heterogeneous inorganic sample, required some more complex and aggressive acid mixtures, such as the phosphoric and the fluoroboric acid. Next, we move into a geochemical application, which is an organic sample. So we had a client who needed to digest 1 gram of crude oil. The reason for the 1 gram was they're analyzing via ICP-OES, and they need to reach their limits of detection within the sample. So what they did was, this is a user of our UltraWave 2. They digested with 40 mil vials. We digested with 40 mil vials using the UltraWave 2, which is now the 7 rack on the UltraWave 3. We ran 1 gram of sample with 10 mils of nitric and 1 mil of water. One of the benefits of the UltraWave is because it can go to such high temperatures and pressures, it is able to work with dilute acids. So by diluting the acid, you're not going to have any negative effects here. So the reason we add 1 mil of water is to quell any exothermic reactions which can occur with the sample. And this is the microwave program that we used, which resulted in a complete digestion, as you can see, of the samples on the right, clear and colorless solutions. Next is spodumene. Spodumene is a rock used mainly in the lithium-ion industry. It's a source of lithium. What we did in this case was we digested spodumene with sulfuric, phosphoric, and HF. The use of the sulfuric and the phosphoric acids, you may have seen from the previous slide, allows for the dissolution of the alumina in the sample. HF we used for the digestion of the silicates that were in there. If you use dilute HF or excess HF, that helps to avoid the formation of SiF4, which is highly volatile. We digested the sample at 280 degrees Celsius for 20 minutes with SRC technology. And by going to higher temperatures, we're able to halve the amount of sulfuric acid and phosphoric acid that was used on a rotor-based system. So as far as method development goes, method development can be very much streamlined in the UltraWave. As you've seen, you can change one variable at a time and change your sample mass or your acids. We have full libraries of all of methods that are built directly into the terminals, as well as in our Milestone Connect. Our Milestone Connect has all application notes, video tutorials, tips and techniques. All the latest user manuals are there. And if you ever have any questions on how to digest any samples, you can always contact us as your local Milestone representative. So now, just to conclude some of what we've spoken about today. So SRC technology is capable of completely digesting a wide variety of sample types, as you've been able to see, from organics to inorganics and complex inorganics. Can handle complex acid mixtures, because many of these are required for digestion of mining and geochem samples. SRC technology can reach and sustain the highest temperatures and accommodate the highest pressures, especially important that high pressure for those crude oil samples. Can handle exothermic reactions better than rotor-based technology, because all of our samples are immersed in that base load. And we have very good control over the temperature with our easy temp technology. And we also have the ability to handle different matrices simultaneously with SRC technology. So before we conclude, I want to just take a 30,000-foot look at your sample prep workflow. Let's do that. Let's take an exercise here. Think of everything you do in your sample prep workflow, from weighing out your sample to doing your analysis. There's a lot of different steps that are in that workflow, such as making sure you have high purity acid, your reagent handling, vessel cleaning, microwave digestion, et cetera, and the process repeats. Are you doing everything as efficiently, as safely as possible? Are you optimizing your laboratory technician's time? Are you minimizing any downtime and human error? So one of the ways we can look at that is with the holistic view of your sample prep workflow. So let's take a look at the different pieces of the workflow and the different solutions that Milestone offers for them. First, you weigh out your sample. The first step we're going to have is our ultra pure acid supply. Many times getting high purity acid can be a challenge, especially if there's long lead times. We've noticed that lead times with COVID, especially since COVID has started, lead times haven't even shortened since then. Reagents can be very expensive, especially if you're working with high purity or ultra high purity, even more expensive. So the way we're able to accommodate this is with our DuoPure. Our DuoPure is a sub-boiling distillation system. This allows you to purify your own high purity acid or ultra high purity acid from reagent grade acids, and gives you about 90% cost savings, up to 90% cost savings if you buy reagent grade and make your own high purity acid. Next, moving on from ultra pure acid supply, we have reagent handling, excuse me. So reagent handling is one of the steps where we can introduce, where there is a lot of susceptibility to human error. So with this, one of the things that we're able to do is to automate the reagent addition step, because you have a lot of handling of vessels. With with our easy fill technology, we're able to automate the sample preparation step by automatically filling your vessels instead of having to manually do it. You also have enhanced safety, because the only time you ever have to handle the acids is when you change the acids on the top. Next is vessel handling. Vessel handling can take a lot of time, especially with rotor-based systems. In order to overcome, for rotor-based systems, we have our EasyCap automated capping station. This is going to make it a bit more user-friendly for opening and closing vessels with our Maxi 24 and Maxi 44 vessels. However, if you're using our UltraWave, there is no need to use this because there is no vessel assembly or disassembly. Moving on from vessel handling, we're going on to microwave digestion, which is what we're talking about today. And for microwave digestion, we have two different types of solutions. We have a rotor-based system, our SRC technology, or ethos up on the left. And then on the right, we have our UltraWave, which is the star of today's webinar. Now, moving on from microwave digestion, we get to filtration. There may be occasions that you do have to filter your sample. Filtering your samples can take up a lot of fume hood space. So for that, we have the SFS24, which is a sample filtration system. This takes up much less fume hood space, can be used for digestions as well as extractions as well. Next, moving on from filtration, we have vessel cleaning. So vessel cleaning can be a time-consuming process, especially if you're using an acid bath, an acid soak, or cleaning your vessels inside your microwave. A more efficient way to do that is with our Trace Clean acid steam cleaning system. This is going to improve your workflow by automatically cleaning your vessels for you instead of you having to do them either on your microwave or in an acid bath. And if you're using disposable glass vials with the UltraWave, in fact, you don't even have to clean those. You can throw those out if your application allows for the use of those disposable glass vials. And lastly, we have your analysis. So these are all the different aspects of the sample prep workflow and the different solutions that Milestone offers to help streamline your workflow. I'd like to thank everybody very much for your time. And with that, I'm going to pass it back over to the moderator.